Welcome to our 2023 Keen Freshman Innovation Challenge. My name is Matt Franchetti, and I'm the Associate Dean of Undergraduate Studies for the College of Engineering at the University of Toledo. The Innovation Challenge, formerly known as the Angel Pitch Competition, has been an annual event since 2014 with generous funding provided by Tom and Betsy Brady. We deliver it every year to give our first-year engineering students a chance to connect to the Keen's 3 C's in a meaningful way. The 3 C's are curiosity, connections, and creating value. Using curiosity, teams form and work together to identify a need in the world around them, and using their new team connections, create value as they develop a pitch and a solution. The process is more focused on the journey of the student teams as opposed to the final outcome. The Innovation Challenge showcases the creativity, diligence, and enthusiasm of our freshman engineering students. Teams have up to 8 minutes each to present plans in a structured pitch consisting of 6 key subject areas. They are the problem identified, the solution to the problem, the overview of the consumer and marketplace, the competitive landscape, the economic model, and finally, the investment proposition. Each team will be awarded prizes and support aimed at helping them commercialize the inventions. I would now like to introduce our winning teams. In first place, we have the Lawn Mower Deck Cleaning Team. They will receive an award of $1,000 to continue their invention. The team consisted of Colton Blubaugh, Gabriella Estrada, and Gavin. Congratulations, team. Our second place team is the Foldable Handrail Team. They will be awarded $500 to continue their invention. This team consisted of Keegan, Alex Post, Kaitlyn Fortuna, and Brady Kerner. Congratulations, team. And finally, our third place team is the Bottle Buddy. They will receive an award of $250 to continue their invention. Their team consisted of Schroeder, McCrea, and Gabby Estrada. I would now like to introduce one of our teams with a brief interview.
What was your reaction to winning?
I was pretty ecstatic. Totally surprised me. I was pretty happy about that, yeah.
I'd probably say I was almost expecting it because I knew that we had a great product. When I first thought of it, it was so unique, nothing else existed for it.
I'm just glad to be a part of Keen. I think it's really interesting. I'm glad I got the chance to be a part of it because it was very important to me that I don't just learn engineering, but also to be able to be an entrepreneur and be able to think on my feet a little bit.
I think it helps you connect both of them, helps you connect the business side to it, to communicate. I'd say I want to continue to work on my build to make it better and to make it work fully, and maybe one day I can sell it.
We know that programs like this are important to the development of the professional skills of our engineering students. Skills developed in programs like this are called mindset and complement the engineering knowledge they gain from their coursework. We call that their skill set. Combining skill set and mindset makes for both a very competent engineer and also a person able to achieve success in their careers. As the College of Engineering, we are committed to graduating not just outstanding engineers, but also entrepreneurial leaders of tomorrow in our society. And we are committed to providing our engineers the personal and professional skills necessary to start and maintain a successful and personally satisfying career in an era where most jobs are not safe over time. It is about seeding and nurturing a mindset and a culture of success. Thank you for joining us today, and I hope that you have a great summer.
This is our product, the Lawnmower Deck Cleaner for the 2023 Keen Freshman Innovation Challenge. I am your team leader, Gabby Estrada.
I'm Gavin.
And I'm Colton Blubaugh.
Lawn mowing is one of the biggest industries in the world. And when you're done cutting, there's always that nasty grass underneath. And on mowers like the Zero Turns, it is very difficult to clean the deck. Well, now with our product, it makes it easy.
Next, we'll be talking about our solution. When designing the lawnmower blade, our main goal was to be able to efficiently remove all of the grass from the underside of the mowers that were too big or heavy to easily flip on their side, much like a push mower. This would prevent the deck from breaking down due to the buildup of grass that would slowly deteriorate the deck over time. To do this, we have attached a steel bar with prongs to the blade that will scrape the underside of the deck, simultaneously cutting and cleaning the grass at the same time.
When developing our product, we incorporated the 3 C's in an entrepreneur mindset, thus opening up new opportunities and ideas for us to explore. When developing a design, we wanted to utilize the mechanics already involved in a lawnmower. We understood that the regular blade spins on a spindle attached to the lawnmower deck. By making connections, we asked, how could we incorporate the motion of the spindle for our product's design? This is when we decided to make our product attachable to the spindle, creating a spinning, scraping mechanism. For curiosity, we asked ourselves, what distinguishes our product from what's already available? Our product is unique because there is nothing like it in the market. Our competition consists of products like pressure washers and hand scrapers, which consume water, time, and energy. Our product is more efficient because it's automatic, meaning no additional work is needed after it's installed. Lastly, after our final designs of our product, we did not stop innovating. We wanted to create more value for our product. That's when we asked, how can our product be improved to increase efficiency? If we experiment with different materials, we may be able to increase our lifespan of our product. When we pair the 3 C's with our engineering skills, we create long-lasting value, ultimately enhancing our product's possibilities. We had a few problems throughout the development process of our product. Initially, our design required us to weld the pieces of metal together. Our group lacked welding experience, which cost us in materials. The next problem we encountered was not fully cleaning all portions of the deck. We fixed this problem by adding more wired prongs to our final design to clean the portions we missed. Lastly, when brainstorming on how to create more value of our product, we discovered the dimensions for lawnmower decks vary. A possible future innovation may be to add adjustable arm feature to adjust the lengths of our blade, potentially creating more value for our product.
Lastly, we'll be going over our next steps for our new product. Since our idea is so new, we will need to be able to perform more trials on different lawnmower types as to see how it may fail as to improve it and really wring out the details so that we know that our product is top tier. We also want to be able to create various lengths. Since not all lawnmower decks are the same size, our blades will have to be different sizes as to accommodate for the lawnmower decks. We know that sometimes, whether it's a riding, zero turn, or a push mower, that they even have more than one blade. So we hope to be able to look at how to accompany that as to really make our work bulletproof. Lastly, we feel that it is very important that we experiment with the other materials as to see what we can build upon so that we can really make sure our product is strong and fails as little as possible. Hope you enjoyed our presentation and hope you decide to help fund us to make this product successful.
Welcome to our Innovation Challenge presentation. I'm Caitlyn Fortuna.
My name's Alex Post.
I'm Laura Keegan.
And I'm Brady, Kerner. And we would like to share with you how we have used the Keen's 3 C's in the creation of our foldable handrail for the Innovation Challenge. When searching for an idea to start off, I had asked one of my friends, as a shot in the dark, if they could think of any problems that they needed solved. And to my surprise, he said, actually, I do have a problem you could solve. He explained that at his church back home, there's a hallway that is also an inclined ramp. And due to building safety regulations, it also needed a handrail on the side of the wall. The problem occurred when they tried to move their instruments up and down the ramp. The handrails stick out too far, restricting the area. On the slide, there is a picture of the hallway. As you can see, the hallway is very small in comparison to the instruments in the back of the picture. So you can imagine how tough of a time it is to get those through. Now, in this picture, the handrails have already been removed in the area where the walls come in slightly. The church needs to put the handrails back on in order to meet the building requirements. So we searched the internet for potential solutions to this problem and found no handrails that currently fit this situation.
So our solution was foldable handrails that can fold down, so that way we have more space to move our things. We also were going to use sturdy wall brackets, that way they don't collapse on us. And it's very unique to the market. It solves a very specific problem of the church hallway being too narrow, but it could also be applied in other fields where a similar problem is encountered.
How we use the 3 C's. For curiosity, we asked ourselves, can we conserve more space in a small hallway? We examined different ideas on how we could innovate the handrail, including having it become detachable from the wall to altering the base design. We ended up deciding on an efficient foldable design. Through connections, Brady's friend confronted him about a problem at his church, and their hallways too narrow to move large objects through. We wanted our innovation to solve this problem and allow an option that wouldn't jeopardize accessibility. And there are no products out there currently that allow you to change the handrail's orientation. We can create this handrail to conserve crucial amounts of space in a hallway while giving flexibility to lower the handrail back down to a normal handrail position. Our product creates value by providing an aspect of multiple utility that can't be found anywhere else. The photos on the right show a 3D model of the handrail designed in Blender. We have a fully animated version of this, but unfortunately, it wasn't compatible with Google Slides. In this design concept, the handrail is slim and it folds down to allow more room while still maintaining accessibility.
Some problems that we may face in the future with our design is we have limited access to strength and testing of materials. We have not been able to determine the most effective material for our handrail, but we want our product to be as sturdy and cheap as possible. So in the future, we would like to be able to test new materials and find the most stable one. We may also have trouble marketing our product because it is a solution to a very specific problem. Our friend had a problem with the handrails at his church, and we came up with a solution to that situation. However, we believe that this design can be easily implemented into any building or structure that requires handrails. Because of this, there's no way to effectively determine a market size.
For our next steps, we want to create a physical prototype to test functionality and strength. We want to install our final product in the church hallway and receive feedback from them so we can further innovate and create more value for it. And we want to find new clients and market to a greater audience and gain opportunities to install new handrails. Thank you for your time and listening to our presentation. We hope you also see the value in our product.
I'm McCrea,
I'm Hannah Schroeder.
I'm Gabby Estrada.
and our product is the Bottle Buddy. Back in the beginning of the first semester, for our freshman design project, we were struggling to come up with an idea. My mom reminded us of a product she had wanted for a while, a device that can bottle feed multiple kittens at once. My family fosters kittens for the Toledo Humane Society, and recently we've been taking a lot more bottle baby kittens. My mom is the one who has to wake up in the middle of the night multiple times to bottle feed the entire litter, one at a time. Normally this takes about 30 minutes for 4 to 6 kittens. She has developed a method of bottle feeding up to 3 kittens at once, as shown in the picture, but this only works for older kittens who can use the bottles themselves and don't need any additional help. She had looked at other products online, but they were all either DIY designs, very expensive, or just wouldn't work for the applications that she needed.
Our current solution is called the Bottle Buddies, which exhibits modular and fully adjustable features. This area is a space for a removable heat pack. This design feature purpose is to simulate the body heat of a mother cat when feeding. The center base is flippable. This feature offers a stable foundation when the heat pack is not in use. The front and side extensions are detachable. This allows the product to be stored easily while also allowing the option to connect multiple units together. This design feature is a mechanism that allows the height of the bottles to be adjusted.
There are also clips for different bottle sizes. Under 40 millimeter diameter bottles take up 2 slots, and over 40 millimeter diameter bottles take up 3 slots. There's also adjustable spacing and modular arrangement for the desired number of bottles. This device can take up from 1 to 6 bottles. There's also adjustable bottle angles that can easily adjust how fast the formula flows out of the bottles. There's also a Velcro attached fabric cover, which makes washing and cleaning the fabric easy. During the process of this project, we have used the 3 C's often to produce a successful product. Based off our original problem statement, we became curious about the best way to more effectively bottle feed multiple kittens at once. While perfecting our prototype, we approached the Toledo Humane Society as well as Mitchell's mom to get their opinions on the project. They gave us valuable advice, such as modifying our product for other animals to extend the usage. They also expressed their concerns about cleaning and sanitizing the product for multi-usage between animals to make sure the material of the product could handle the sanitizing they need to do for the health of the animals. After testing our product, it is evident that it makes the lives of the user easier with more efficient bottle feeding. There are not many products similar to ours on the market currently, making our product stand out. Our product is also more affordable than similar products on the market, increasing the value of our product.
The two biggest problems we've encountered has been tolerances between the parts and parts breaking. The tolerances have been very difficult to get right because the parts have to be easily removed, but they also can't fall out during regular use. As a result of bad tolerances, many parts have broken, including the models that are currently being used for testing. We have spent the past 6 months improving upon our design using about 4 kilograms of filament. Also during this, we switched to a different filament which presented a lot of issues, the most were related to the 3D printer, not the design. There was a 2-month period where the 3D printer we were using was malfunctioning and had to be repaired, which meant that our design process was interrupted.
Next steps. We intend to improve the design and repair any broken parts. Then we plan to connect with Toledo Animal Rescue and Maumee Valley Save a Pet to proceed extensive testing on the product. We also will be adding a removable foam pack on the back of the base under the fabric cover to support the fabric and provide the kitten something to knead against while the bottles are at greater height.
We will be delivering a unit to the Toledo Humane Society for additional testing, and over the summer we will continue to improve upon the design.
All right, so my name is Ethan Beach.
I'm Ayden Kretz.
And this is our innovation. We call it the basket cart. So the basket cart is basically just like a grocery cart and a basket hybrid. So we, as you can see from our sketches, is that we are taking a grocery cart and we're combining 3 different baskets that clip into the cart and unclip so that you can carry around the baskets wherever you want to go. You're not just limited to the cart. Our bottom left, you can see our brainstorm sketches. The top left is the basket and the cart together and how they sort of click together. On the bottom is just the cart, and then on the right is the side view and just the trigonometric view of the shopping cart. So we're gonna have 3 baskets attached, and the buttons work sort of like a seat belt. So you press the red button, it releases the basket. And if you want to put it back on the cart, you just stack it onto the clips and they snap together. So our main purpose is to reduce shopping time. So if you're with like a big family, let's say you have a family of 4, then one person can have the cart and then 3 people can have the baskets, and they can all split up and reduce their shopping time. Not only that, but it also makes it easier to shop if the store is packed, so you're not just running into shopping carts. Like I said, you're not limited to the shopping cart. You can tuck it away somewhere close if you want to grab something real quick and just pick up the basket. Another feature is that you can organize the items inside the cart. So with a normal shopping cart, you got all of your groceries thrown together all over the place. With the basket cart, you can separate your items efficiently. You can put frozen in one basket, fragiles in another, and you can keep your cart just well organized. With that, it can also reduce damage from other items. So like bread and eggs that break easy, you can put it all into just one basket so that you can protect it from all your other groceries that could fall on top of it and break them. We are still having like the bottom tray that normal shopping carts have so that you can put heavier items into the cart. And once again, it doesn't get in the way of the baskets or it doesn't break any items that you have. If you forgot an item in line, instead of pushing just the shopping cart and losing your spot, you can leave it there and just take the basket with you, which is another more efficient way. It can keep your items cool. So just like the organization, if you don't want to have your items scattered, you can keep them all in one place. You can just put them all into a basket. And then finally, it's easier to unpack your groceries into your car instead of just leaning in, grabbing all the groceries that are falling out everywhere. You can just pick up the basket and you can do it that way. So that we applied the 3 C's in our project. The first one was curiosity, where we try to figure out how we can make an everyday task that everybody uses easier, and what better way to do that than shopping? Since most people just do shopping, they don't really think about it. We wanted to try to innovate, just something that people do like almost every day. Connections. So this was a pretty fun one. We had to research different stores and different model types to come up with a unique idea that would work rather than just throwing 2 things together and not really having a system. Different stores also had different carts, so it was pretty fun to kind of investigate and see like what they had and what we didn't and what we could improve on from that. Finally, we created value. So we went through different ideas and sketches, and like you saw the SolidCAD drawings, we modified them to determine which one was more efficient. And going through the sketches, we had a great time.
Some of the challenges we had was the engineering standards of carts. So we had to research like what were the dimensions of carts normally at stores like Kroger and Myers. We had to figure out what kind of metal they use, what kind of plastic they have, and that little handle that you push it. Basically, just getting all the information we need to actually design the cart, and that goes into creating an accurate sketch. We did AutoCAD, which went to SolidWorks second. And the SolidWorks was a pain to do because we had to get all those little rods that you see on the shopping carts, different sizes. It took a lot of time, but eventually we were able to get it working along with the 3 baskets that went inside the cart. Budgeting was hard because at our current level, we can't really make a shopping cart. That takes a lot of welding and just metal cutting. So we'd have to go out and buy a shopping cart, which isn't exactly cheap, along with any of the other materials we need. And then obviously the last one is what materials work best. This was just researching for if we continue this, what materials would we use to actually build a cart, which ones would be the cheapest while still functioning properly. Materials that we used in this design was we had to buy 1 shopping cart, which was the heavy duty plastic kind, not the metal kind. We bought a shopping basket with handles, also plastic. We'd have to buy 3 of those since our plan is to separate into 3 different compartments, and we'd clip that on using the forklift seatbelt, which would go on each side of the baskets that go into the cart. And then the access plastic to modify basket, we changed up the basket design a little bit just so it could slip in easier to the cart. For our budget, like I said, the shopping cart's expensive. There's anywhere between $100 to $150, depends on who you're buying from. The shopping basket with handles was $8.91, so that actually wasn't too bad. The forklift seatbelt was $33.10, which is a lot more expensive than we thought. So one of the things we could improve is just maybe buying less quality seatbelt that will still function the way we want. And then the access plastic that we use to modify the baskets in the cart just to fit it in better was only about $5, which brought the total to $172.01. Next steps, we obviously got to advertise it, get the info out to the right people, mainly maybe some small stores, maybe some big stores. We'll see who takes it. We need to get a patent on the product to make sure that it's our idea so that other people can't just come in claiming credit. Test different ways to modify it. We can maybe modify the basket and the cart to make them fit in easier, make it more accessible to everyone. Just tons of different ideas we can bounce off to make it as efficient and just beneficial as possible. And then the final one is just the different materials to make it cheaper. Obviously, we want the product to still work, but we want to make the most money we can. So we want to also make it as cheap as possible. So we got to find a way to balance that out.
So if you have any questions, below is our contact. Thank you for listening to our application for the Innovation Challenge. And yeah, just let us know if you have any questions over it.
Hello, I'm Noah Bittel.
I'm Colin Houpt.
I'm Anna Mullner.
I'm Parker Preuss. This is the Control Center.
Starting off with the problem statement, we use the forgetting curve
which states that you forget about 50% of the information that you intake within an hour. And we put it into a survey. 56.4% of our servants said that they forget where they put their remote when they set it down and they don't have a designated spot for it. So we used that and we started researching. Some of the competitors' designs were smaller, like this one on the right, that holds a controller, but it uses batteries and it's also very small and not very aesthetically pleasing. This bigger design on the left, it holds more, but it's bigger, not as aesthetically pleasing, and it couldn't charge it anything that was inside being stored. So we wanted to make something that kind of combined the efforts of all of those.
So this is why our solution is better. First, functionality. The control center provides a place to store a controller and also allows you to charge it at the same time. The size doesn't take up much space, could fit comfortably on a shelf or on a desk in your setup. The aesthetics has a nice sleek metal finish and customizable colored lights to match your setup. And modularity, you can stack multiple units on top of one another with a peg and hole system so that it's stable, and you can accommodate any number of controllers.
So this is how we use the 3 C's. We were very interested in finding a solution to, like we said, putting and finding a place to put your controller so you don't lose it, as well as finding a new way to charge it.
And with doing this, we were able to take the charger and we have it coming through the back of the box through a hole so that there's no loose cords or anything that's out, it's not messy, but you can still charge your controller. We also added the little holder that holds the controller up so that it actually shows the controller instead of it just sitting on its back. And we added the LED lights, which we saw from a couple of other designs, so that it would look better and it would give it that aesthetic please that we were looking for.
For creating value, we decided that we should take a survey to see how much value we'd actually be providing. We had about 364 responses, 74.1% of which said they did not have a place to store their controllers. 51% said they lose their controllers often. 68% said they wanted to see a solution to the problem, and a whopping 76.4% said they believe our product would help them solve their problem.
All right, so a few problems we encountered. First of all, obviously, we have a sleek metal finish on this. It's made out of aluminum, which means it's a bit expensive. So in the future, if we were to manufacture this, we could use more common plastics, which would be much cheaper. Another issue we had was research. Obviously, there's not a whole lot of information or surveys out on misplacing controllers and charging controllers. So we, had to use our own personal experience, conduct our own research and surveys in order to obtain that information. And finally, we weren't really well versed with circuitry or electronics, so we had to sort of learn how to not only, wire and circuit things, but we also had to figure out how to do it in a compact area.
So this is our next steps for the future. One of the things we want to implement is UV lights into every one of the boxes that will help disinfect the controllers when you place them in there to charge. So it'll be very helpful to the user because they won't have to spend time doing that themselves. Our product will help them do that without their effort. And we also want to create a modular power system so that when you stack it, you don't have to charge every individual box. They'll all be charged by one cord instead of each one being charged by a cord, which is what we have right now. And we also want to add horizontal modularity options to cater to different spaces and gaming setups that each user might have. And we also want to create a mobile app for remote activation so that you yourself can just click and start charging your controller and you don't have to always go to the setup. You can do that on your app.
Our idea for the Keen Freshman Innovation Challenge is a cup holder insert that fits into any cup holder in a car. I'm Jack Siedel and my partner is Caleb Christen. The problem statement. In my car, my water bottle would never fit in my cup holder, and I thought there had to be a better way to secure my water bottle when I'm driving. When I am driving, I would always have my water bottle in between my legs, which isn't a good or safe idea, or in my passenger side seat, but it would always roll onto the floor, distracting me a little bit when it hit the sides of the door. Cup holder in most cars have a diameter of 2.5 to 3 inches, according to Home Niche. My water bottles have a diameter of 3.55 inches, according to Hydro Flask, so they never fit. And as you can see in these pictures, these water bottles are too large for the cup holders. The solution was to make a cup holder insert that would fit into any size cup holder and be large enough to fit any sized water bottle. The cup holder insert features 3 prongs that extend outward to fit into the car's cup holder. You would twist the top part that holds the water bottle, which extends the prongs, securing it into the car's cup holder. The cutouts on the side are for any cup or water bottle with a handle, such as a mug or a Stanley cup. The part on the right is the lid that would adjust onto the water bottle so it would not slide around the insert, creating a more secure fit. The lid uses an iris door mechanism to close around the water bottle. What's unique about our product compared to most on the market is that it includes this adjustable lid. You can also use the cup holder's insert without the lid and it will be just as successful. While designing our product, we tried to keep the 3 C's and the entrepreneurial mindset in the forefront of the process. We were curious how we could modify an everyday item to be more inclusive and fit different sized water bottles. That is where we came up with the idea for the adjustable cup holder insert. For connection, we wanted to give people the ability to hold larger water bottles in a smaller cup holder. To create value, we created a more in-depth cup holder insert. That way, people that had larger water bottles could fit their water bottle in a smaller cup holder. During the design process for our project, we encountered a few problems that made it a little harder for us to work on the project efficiently. Some of these problems included struggling to come up with an idea, scheduling meeting times that would work for both of us, and modeling the moving components. Our next steps for our product will be to create a working prototype. This will most likely be 3D printed to lower the cost of production. We also want to conduct more market research. We want to find out more about what the market for such a product would look like, as well as how much we should sell each cup holder for. We also want to test the product in real-world situations, such as using the prototypes to test out different real-world scenarios, like how it holds up to different kinds of stress, or how well the adjustable top can keep the water bottle in place while driving.
Our entry for the Keen design project this year is the Dorm Door Jam. I'm Ryan Dick, team leader with my members
Shawn Hodge, Drew Dafoe.
And we decided to design a project that was aimed at security for low budget living accommodations. Usually you're not allowed to modify the place that you're living, and we decided that this cheap alternative would be a good way of providing a little extra security for not a lot of extra money.
So for our market analysis, we made this product to provide a cheap alarm system for students or adults in low-income circumstances, such as the students living in the dorms who can't modify their place of residency for safety. So the current alarm systems usually have a permanent installation or have an expensive electronics and locks. To answer that market gap, products that act like large door jams, a bar from the door handle to the ground, exist and direct the force applied to the door into the ground without allowing the door to open.
Our competition overview. Our idea is to innovate a doorstop design by providing a built-in alarm feature into a door stopper. This product does not necessarily mean that it will cost more than our competitors, but it is a major deterrent for burglars who want to enter their way into the domicile. Because of this, their presence will be announced, and their attentions to anyone in the general area will also be known.
So the 3 C's for the Keen Design Project are curiosity, connections, and creating value. After discovering that one key can open multiple doors in one of the campus residence halls, we were curious if we could stop unwanted entry cheaply. We connected stopping entry and alarms in our design and tried to be as portable as we could. We also learned about more and about the cost versus benefit of combining 2 products.
Some of the problems that we experienced during this prototyping phase was that our product did everything we intended it to, but it didn't do it particularly well. It would prevent people from entering the door, but it was mostly made out of plastic and wouldn't hold up very long. We found that out when we dropped it later and don't have it here today with us, but it also could collapse to be carried around, but it didn't collapse as far as it probably could have with a little more redesign, and it isn't particularly loud or annoying of an alarm. All of this could be fixed with another redesign in the future, but the main problem that we faced during the actual phase of prototyping was that we couldn't effectively find a off-the-shelf switch that would do what we needed it to do. So a lot of our time and resources were given to developing this switch and making sure it would function properly. And we kind of overlooked a few of the other things, which is very important in the design of this product. We learned a lot in creating this prototype and a lot about what it means to really think through the problems and be a proper engineer. So I think that to properly carry this out, we just need another redesign and a little more attention to the finer details. I'm glad that we could do this project and enter it into the Keen Design competition this year, and I hope that we've been excited you to see how our project turned out. Thank you very much.
So for our project, we decided to do an emergency response drone. This presentation will be presented to you by Alexander Macke and Dylan Berkmeyer. So first off, we have the problem. The first problem being that there is a lack of safety while walking on college campuses. On average, there are about 18.7 college crimes that occur per 10,000 full-time students a year on college campuses. The second problem being that there is a far too long response time for emergency vehicles to get to the scene of an accident. So on average across the US, it takes about 9 minutes for the first emergency response vehicle to get to an accident. And how the problem is solved today is, today people just call 911, then the emergency vehicles drive to the scene of the emergency, where the drone would increase the response time and allow for early assessment of the scene with its video camera, which would give the responders an edge when fighting fires, crime, and etc. So our solution is better because in the terms of campus safety, our solution would be used to essentially have a drone come to your location and walk with you to your destination. These drones would be able to send live feeds to the police with either the click of a button, or when technology gets better, it would be able to detect that something is wrong and automatically send live feed to the police. And for emergency response time, the solution would be to send out a drone when dispatch gets called at 911, and the drones would be able to take off, go to the emergency, and get live feed and send it to the emergency response vehicles, so that way on the way to the emergency they would be able to get a plan formulated or some other idea of what they're going to do when they get there, so that way it doesn't take them as long to start saving or helping with the emergency as it would if they have to get there and plan.
How we used curiosity, connections, and creating value in our project. So we were curious in bettering our campus and emergency response force. Our connections, our idea is a long shot, but with a lot of help and assistance, we would be able to complete this project or at least get a prototype started. We would first likely start on a small scale and run many tests before bringing it to the field. So likely we would start with the campus safety drone first, and then we would work our way towards the emergency response drone. The reason for this is campuses are small, and the campus is also a great spot to do testing because it's kind of like a mini city if you think about it. And there's a lot of people out at night, so these drones would definitely get used frequently. Creating value. We believe this is a unique opportunity because drones are now able to fly themselves. So why not use them here at home in like emergency response or on campus to take preventative measures and to increase response time? Two great things that are needed. And a lot of times these drones right now are used in the military. So we could just kind of not copy and paste, but kind of change the drone around a little bit and make it adaptive to our needs here in the U.S. Problems in the journey. The biggest problem is not having a prototype. We had little to no access to resources and little to no access to high value technology. The main reason being is just because it's expensive, and basically that comes with our idea will be costly if pursued in the future, just because the technology is so high up there that it just takes a lot of manpower and a lot of price to build one of these things. We definitely could use assistance, and that would definitely help us and push us along in this project. And definitely having a prototype would have enhanced our project and presentation intensely. This kind of goes along with the last slide. The next steps would be to gain investments, funding, and then do more research. We would then build a prototype of the campus safety drone. Reason being is just the campus is small, easy to test on, so that would definitely make it easier. And likely this drone will be less expensive than the emergency response drone. We'd then work with college campuses, especially the University of Toledo and nearby campuses. We'd then review data collected from this testing, and then maybe even work with the government on funding, building, and testing the emergency response drone. And once this is all completed and everything is to quality liking and doing good and actually showing benefits, we would then bring this to the real world for use in our daily lives, and hopefully by then it's having a positive impact on everyone's life. And that's just what we wanted to do. That's just the whole idea. I think when you look at engineering in general, I think the biggest thing is we just want to help people out in any way we can, whether it's putting stuff together to help a little kid or do something big like this and actually someone's physical life could be on the line. I think that's just what we're all here to do. So this concludes our presentation, and thank you for your time.
Hello, my name is Blake, and with me I have Jesse Agee and Aubrey Morlock, and today we will be discussing the iFan. When looking around for ideas on what innovation or what product idea we should bring to the table, we kind of went close to home here and went right what's in front of our fingers, and that's our iPhone. And we see that our iPhone almost constantly will die one time out of the day. So we wanted to develop an idea where our iPhone would be able to have a little bit longer battery life for those people that are walking to class or going to work that are not available for a charger. So we noticed that over 116 million people in the United States own an iPhone, and that the average battery life of an iPhone is 10 to 17 hours. And most people I know use their iPhones for work, so at the same time they might be traveling while they're working. So we wanted to develop an idea that would help these people not worry about their phone dying while they're working. So the product that we ended up coming up with was a portable fan that attaches to the iPhone to charge your phone, or that could connect to another cable. Some things that we wanted to improve about our product was the fan design, so that would convert energy at a better rate, which would help charge the iPhone faster, which would also reduce the time spent charging the phone. We also wanted to reduce the cost, as we think that a portable charger does not cost that much to produce and make, compared to the other competitors out there on the market. When discussing the 3Cs within the group, we really wanted to focus on what those 3Cs meant to our product and to our own idea. We wanted to establish a base and understanding that these 3Cs will be the basic outline for our product as we push it into the market. To start off with curiosity, we wanted to see how can we make the fan convert energy efficiently, which we can relate back to our improved fan design, which is one of the main focal points we had for making this product. Making not only an efficient product, we can also try and make the most efficient, cheap product for our customers, while that still maintains a source of income to keep making the product. For connections, are there any other products like this on the market? Do you see any other wind-powered chargers on the market? No. You may see portable chargers, you may see the crank ones that we provided in the other slide, but we have not seen yet a wind-powered portable phone charger. So we think we are stepping our foot into the water with this kind of product, and that we think we can make a big difference when directly comparing our product to other competitors. Are there any other competitors that have a similar design that might be out there? Maybe, but there are none on the market at this time. And for the last C, creating value, we wanted to really focus on how we can make a low cost efficient design for everyday use. We want to improve our customers' well-being while also having the idea that we at the same time are saving money, making money, and being able to sort of branch off and maybe make other kinds of wind-powered charger products, or step into the not only iPhone business of the world, but step into the Samsung business of the world too as well. There are certainly 3 problems we have encountered while trying to develop a wind-powered portable phone charger. For the first one, the 3 of us in the group have no access to background information with wind energy. Myself, I am a chemical engineer, and I have kind of strayed away from the environmental side, and the 2 others in my group are not necessarily involved with energy, but more economic sides of like dealing with numbers and money. Our second problem is we do not have the skill set to build the model and develop the 3D prototype that would essentially be our dummy-based model to build this product. We don't have access to a 3D printer. We don't have the knowledge to even design this. The blueprint would not be spot on as someone who has knowledge with a 3D printer that could make this product. And for our last one, it was accounting for the different kinds of phones out there on the market. With iPhone rolling out phones every year, we really cannot be certain on if our product is able to change or adapt. And that was one thing we really want to focus on, is the ability for our product to adapt for other products as well. So accounting for different iPhones will not only, I feel, help us target different kinds of customers, but also make us more money. Some next steps for the product that we had in mind. We really had 3 ideas to develop, test, and create it. We want to develop a 3D model of the prototype. So getting our hands in on a 3D model, 3D printer to make this product to see if it'll actually really work. We want to test if after the product, if we know it is going to work and it's going to be efficient, we want to test how efficient it's going to be. How much battery life can we get from a single charge of this wind-powered portable charger? And lastly, we want to create. We want to make a market plan that's going to introduce our idea to customers that have never seen this idea before, and specifically target 3 types of customers. Some runners, athletes, people that carry their phone while they run, people that put it in a pouch in their arm. They necessarily could replace the pouch and have the wind-powered portable charger while they're running to charge their phone while they may be listening to music or other types of like books, audiobooks. Daily walkers, people that walk to work every day necessarily may need to have their phone charged after a missed night of sleep. So having that wind-powered energy charger in a windy city necessarily would help them get a fresh start to the day while not worrying about their phone dying. And then lastly, college students. College students are walking to class almost every day. They may walk miles upon miles to go to all their individual classes, and their phone may die while they have classes from 8 a.m. to maybe 6 p.m., 8 p.m. at night. So really, I think runners, walkers, all types of people that are outside being active would be a good customer target.
Okay, my name is Noah Woods.
I'm Ethan Ritchie.
And our idea is called Odin's Notes. Okay, midway through the semester, I found myself really having to buckle down in order to do well in my classes. I'm not really one who normally likes taking notes myself, but especially with Calculus 2 and Physics 1, I really needed to start doing this, but I came into a problem. I'm not a very organized person, and going from not taking notes at all to needing to take really good and diligent notes for all my classes has really put me behind in my classes. I saw one of my buddies take notes on their laptop, and I thought, oh, that's great. I hate writing anyways, so I can just do what they're doing, but I came into a problem. Especially with like calculus and physics, it's really hard to take notes when you're doing things like derivatives, integrals, and other complex math problems.
Our solution to this is Odin's Notes. Odin's Notes is a web-based platform that allows you to take and organize notes on a computer effectively. The features of this program are easy-to-use special characters, ready-made format templates, easily understood organization features, and sharing features that allow you to share your notes with other classmates so that you can help each other. On the right, we have an example of what the program currently looks like. On the top, there is the overall course view where you can see all of your courses, what your different things that are contained within those courses are, things like calendars and reminders, and then on the bottom you have where you would actually input your notes that would then be accessed through the main menu.
Okay, this is how we use the 3 C's in entrepreneurial-minded learning in our project. For curiosity, we wanted to think about how we could bring notes up to the modern age. Through COVID, a lot of our programs and learning has been done through online asynchronous workflows, and we wanted to bring that one step forward and taking notes as well to try and go as paperless as possible. And we were inspired by other programs such as Blackboard that we use at the school, Microsoft Outlook that we also use for communicating between teachers easier, other social media platforms just like Discord, and other platforms that make it very easy to input special characters and do math like Desmos. We also plan on creating value by making our project completely open source and community driven. What that means is that our code will be completely open to access for anyone to edit and modify, which means that someone who is in a more niche field who needs more special requirements that we haven't offered in our program yet, one of their compatriots might have already submitted code that allowed it to work better with them. It just allows everyone to contribute to making this a collaborative project, and allows everyone to have notes easier.
So, the problems that we ran into during this project were that we are not programmers. While we know how to code, we are not professionals at this, and so a lot of the problems that we ran into is the online and local functions are currently not integrated. They don't work together, but they would in the final version. And also, neither of us are really skilled enough to make a modern and intuitive graphical user interface. The final component to the problems that we had is this would need to be hosted somewhere on a 24/7 basis, and we don't have the capital to host it on a server that would do what we needed it to.
Okay, the next steps that we plan on to make our project better. First off is we need to bring people onto our team who are better familiar with code and can better integrate the graphical user interface with what we want to do. And we have already gotten a few connections that could potentially do this for us in the future. However, they haven't fully committed to do that as of right now. And whenever we do get a first prototype, first working online prototype finished and ready, we plan on taking that and putting it on a website hosting service to try and test out to make sure none of the code breaks and there aren't any bugs in our system. And then after we make sure that's working, we might want to test on a small sample size like one of our classes in college, for example. And that's pretty much Odin's notes. Thank you for your time. We appreciate any feedback you may have.
All right, our project is side mirror glasses.
So around campus, we've noticed that with the VO electric bikes and scooters, that there have been several near accidents between people riding the scooters and pedestrians. So we wanted to design a product to improve the safety of students who are using these modes of transportation to get around campus, but also those who are walking around campus. And although there are similar solutions on the market, our goal is to find a portable and versatile option for the average college student that they'll actually use.
So our solution is gonna not only make it safer for riding the bikes and the scooters, but it can be easily attached to any sunglasses or glasses, no matter how thick or thin the frame is. And the mirrors can actually be adjusted for better sight lines. And a lot of the other products on the market don't have an adjustable arm that allows it to be bent for better sight. It's also going to be a lot more portable than the bike mirrors that are currently on the market that like attach to the bike or scooter itself.
Okay, so the 3 C's are curiosity, connections, and creating value. For our project Curiosity, we had used to figure out how the product would be accessible to an everyday person, being college students, make it affordable, make it something they'll actually use, and something that will help in the situations we're put in. Connections. Our design kind of reimagines the car side mirror that has been used since the 1920s. It's obviously a good concept because it's still used today, but just moving that into the bikes and scooters. Creating value, we're trying to expand the market because it's a product for everyday use, not just limited to the cycling mirrors used before.
The problems that we encountered while designing this is mainly how to attach it to any glasses, no matter the frame size, just making it as versatile as we possibly can. And also creating a product that isn't super bulky and is super portable while also serving its purpose, and also staying in a good shape, because if it's used by college students, it's going to get thrown around in a book bag or in the car or something like that. So making something that's going to last.
Okay, and finally our next steps for this product, we want to build and test it out to see just how our design holds up to everyday use. Obviously testing materials that are lightweight and durable, but will definitely work for our situation. And then as we test and build prototypes, tweaking our design and making improvements to our prototype.
Maddie Johnston.
I'm Wes Moser.
I'm Dylan Cross.
And I'm Mitch Clark.
And our codes project is the solar-powered flashlight.
So the problem with modern solar flashlights is that many solar flashlights are either dim, expensive, or have very short-lasting battery lives. Low competition is slowing technical improvement for solar flashlights. A solar flashlight should be small, bright, and long-lasting. And below is a chart describing the issues. Large solar flashlights contain a longer battery life, but are annoying to carry by size. Many solar flashlight manufacturers attempt to save battery life by decreasing lumen amount, which means it would be a very dim light produced. And a lot of solar flashlights that have decent light range between 40 to 80 meters and good lumen output of about 100 to 200 lumens suffer from short battery lives. They typically only last about 2 to 7 hours.
We have other products in the market. As you see down below, you see that all these flashlights are expensive, but with our product, we want to make it more cost effective and better for the consumer. Our product is vastly more affordable due to replacing the need to keep replacing batteries in our flashlight and only needing solar power. Our flashlight's battery is greater than regular batteries because our energy storage is stronger and uses less power to generate light than regular AA batteries.
We use the 3 C's in our product design with the flashlight in multiple ways. For curiosity, we wanted to make a flashlight that is lower cost and wanted to decide how we can make a product that is lower cost. For connections, we wanted to connect what kind of technology we could use to help achieve our goal. What kind of technology would we need to learn to handle, to understand, and to create value. We wanted to create a product that costs less initially and also costs less in the long run. With solar-powered flashlights, you don't have to pay for batteries, which can lower costs in the long run as well.
Some problems we encountered while designing and coming up with the idea for our solar-powered flashlight. One problem we encountered was the skill set to design a prototype that would lower cost overall. We figured that we'd probably come into 3D printing and modeling for our actual design, including both the battery and the overall idea of the flashlight, and also a knowledge of the industry, an industry being the consumers of who we would sell to, how we would sell them, and how we'd market them, and also the industry of designing and creating the solar-powered flashlight. And with that also comes the knowledge of electrical circuits and solar-powered energy, and that comes down to how can we properly build and create with our idea of a long-lasting battery with high power.
And now for our next steps, we would have to create a prototype to present, test the prototype with a select audience, gather ideas on how to improve our design, redesign prototype if necessary, and create a long-term business plan with costs, sales price, and expected profit.
The project is on the attached heartbeat synthesizer, an attachable device that provides an adjustable mechanism that mimics the heartbeat of a prenatally exposed baby's mother. The problem is in the United States, about 10 to 11% of all infants are born exposed prenatally. That's around 400 to 500,000 babies. Being prenatally exposed can cause a variety of issues after birth, mainly developmental and physical setbacks. These infants can experience difficulty sleeping, and sleep deprivity in children can cause brain development problems, growth issues, and more frequent illnesses. Prenatal infants need aid in sleeping to prevent underlying health complications from developing. The maternal heartbeat is the first regular and periodic stimulus that the fetus receives, so it can influence the subsequent preferences generalized to many other slow rhythmic sounds. The same short-term calming effects can be elicited in newborns by other rhythmic noises. The concept and design is something to imitate heartbeat. It has internal components. It's completely analog, made of a PLA plus shell. And this is something that isn't really comparable to any other product that's being made right now. It's kind of filling a market gap. The 3 C's, curiosity about what prenatal infants sleep better. To prevent health complications lead to the development of the attached heartbeat synthesizer, when we discovered that the mother's heartbeat or something that mimics that could help prenatal infants sleep. Connections, researching the problem and if there were any other previous solutions helped create a connection to possible solutions. Connecting real-life problems with our education, produce a new product that can help prenatal infants sleep without developing serious health complications. Creating value. We're creating value by filling a market gap for a problem in prenatal births that has not been addressed by modern technology. Some of the problems encountered while we were creating this were we needed a 12-volt instead of a 5-volt power source, and there were soldering issues without the proper PCB board. Conclusions. The next steps are to be tested at a hospital, to switch to a 12-volt instead of a 5-volt power source, figuring out the soldering issues, by getting the proper PCB board, and using sewn elastic.